Hello! Now, in the last video, we were talking about this thing called variance and standard deviation, and we established that essentially what we're doing is just looking at the distance of each value from the mean, and then just taking the mean of all of those distances. So, for example, we'd look at each value, we look at each distance. Okay, so this would be distance 1, this would be distance 2, distance 3, and so on and so on. So on right the way through distance n, and then we just take the mean of them. But we had to do something before we just took the mean of them, because of course we'd have some values above the line, and we'd have some values below the line. So there'd be some positive values, and there'd be some negative values, and what would happen otherwise is that when we added them all together, we just end up with cancellations which occur. So in other words, we just needed to make them all positive, and the way which we did that was just by squaring each individual value. And then we just took the mean of that. Okay, and then if we wanted to get back to a value which was more like the distance, then we just take the square root. So we'd square it, then we'd square root it. For example, if we had -3, okay, we square it, so that comes out as 9. But then if we square root it, so 9 square rooted, it would come out as 3, which is just the positive value of -3. Another word of that is modulus. Right, so essentially what I want to do now in this video is I want to try and introduce some formulas, because there's lots of different formulas you can use for variance and standard deviation, but all of them look roughly the same if you understand what's going on. So the important thing which you have to get into your head is that all I'm going to do is just I'm just going to take this horizontal white line which corresponds to the mean, okay, and then I'm just going to take some random distances above and below the line, which is what I've done down here. Okay, so I've called my distances above the line, so the height which this distance reaches is 20, and I've called it x1, then the height which this distance reaches is 15, and I've called it x2, and hopefully you can see what's going on. By the way, this is just some conventional notation. You know, the mean, because it's so useful, we actually give it some special notation. Okay, so let's say, for example, I'm dealing with values and I'm calling my values, my variable is x. Well, if the mean of those variables or those values, I'm just going to stick a bar above it. So x bar just simply means the mean, okay, which is why I've written it like that there. And that's important because I will use that notation in just a moment. Okay, so first steps first then, I have to work out the distances of each of these. So I need to work out that distance and that distance. So let's give it a go. So the mean is 18, and I want to work out what is the distance from 18 to get to 20. So what is the distance from get from 18 up to 20? So the way which I'm going to work that out is just simply by saying, right, I'm going to do x1 minus 18. So I'm going to do x1 minus 18, so it's going to be 20 minus 18, so it's going to be 20 minus 18, which comes out as 2. So my first distance, my distance 1 if you like, is going to come out as 2. Okay, similar kind of thing for my second distance, so d2 is equal to my x value, which is x2, okay, minus my mean, so x bar. Okay, so it's going to come out as 15 minus my mean, which is 18, so that's going to come out as -3. So my second distance there is -3. Okay, what about my third distance here? So my third distance here, my x value, so I'm now looking at distance 3. So d3 is equal to, x3 minus my mean, minus x bar. So that works out x3 is at 22, my mean is at 18. So what's the difference between 22 and 18? That's 4. So in other words, my distance 3 is 4. Okay, so now let's look at my distance 4 then. So I'm going to be looking at this distance here. So distance 4, so d4 is equal to, well, it's going to be x4, the difference between x4 and my mean. So this distance here, which works out as 17 minus 18, so that works out as -1. So d4 works out to be -1. So here are all my distances, which I've completed now. Well, how did I get my distances? So in other words, my distances was just worked out by taking whatever my x value was. Remember, my x value was just my height. It was just my height, whichever I'm at. So this is just going to be x. Maybe if I colour code it. So D was in green, wasn't it? So my distance was just equal to my whatever my value was, so whatever the height of my peak was, okay, take away my mean value. So the difference between my height of my peak and my mean value, okay? So what's the next step then? How do I work out the variance and how do I work out the standard deviation? Well, standard deviation is easy. I'm just going to take the square root of the variance. So how do I work out the variance? Well, my next step then is to square all these values together. So I'm going to do d1 squared plus d2 squared plus d3 squared plus d4 squared plus d5 squared plus d6 squared plus d7 squared, okay, and then I'm just going to take the mean of all those values, so I'm just going to divide through by 7. So let's try and come up with a general formula then. Well, how did I get each of those, how did I get each one of those distances? Well, the distances was just worked out, so the distances were just worked out by this formula up here, which was equals x minus the mean, so whatever the height of my peak was, minus whatever the mean was, okay, and then I've just squared all those. I've squared each one of those, okay, and then I've just added them all together. So remember that the formula for adding them all together is just the sum, okay, so just taking the sum, and then I just divide through by n. So actually this is my first formula for my variance. Remember, I can just call variance, I just tend to call it VAR because I get lazy. So the variance is just equal to the sum of x minus x bar all squared divided by n. Now, if I just showed you that at the beginning, that would look quite complicated, but hopefully you followed the logic of where it comes from. I need to look at each of those distances. Well, how did I get those distances? So d3 was equal to x3 minus the mean, okay? I then need to square it, so I just square both sides, okay? I add each of the distances together, which is why I use that sum there, and I just take the mean of that, which is why I divide through by n. So that's the first formula for the variance. Now, there is also a slightly different way that I can think about variance as well. I'm still thinking about distances, but I'm thinking about the distances not as distances. Let me show you what I mean. So in other words, I'm just going to literally look at these values here. Okay, first, I'm just going to take the mean of these values here, okay, and then I'm going to take away the mean from that. So in other words, I'm working out the distances at the end. So let me try and show you. So in other words, I'm just going to literally take these values, okay, but notice I still might have negative values in, like I do with x4 here. So I'm just going to literally take each one of these values, so x1, so I've got to make them all positive first because, you know, like I say, I could have a negative value. So I've got to square them first. So x1 plus x2 squared plus x3 squared plus x4 squared. Okay, then I'm going to take the mean of that. So if I take the mean of that, so let me just try and work that out first of all. So x1 was 3. So I've got 3 squared. x2 is 1. x2 is 1, so I've got 1 squared. x3 is 4. x3 is 4, so I've got 4 squared. And then x4 is negative 1, so I've just got negative 1 squared. And how many have I got? Well, I've got 4. So let me just try and work that out for you. So I've got 3 squared, which is 9, plus 1, plus 16, plus 1, all divided by 4, which comes out as 27. Divided by 4, so what's that? 27 over 4. It's roughly, so it comes out to be roughly. Do you know what? Let's just make that 28. Just because for the purposes of this video, I know it's not, and I know you're probably going to have a go at me because I've just broken maths, but I'm going to call it that just because it makes the maths easier. So let's say this is 7 now. So in other words, I've taken the mean of all these distances and it comes out as 7. Then if I take away 2 squared from that, so I take away the mean squared from that, then that comes out as 3. So the average kind of variation, if you like, is 3. So in other words, all I'm doing then at the last minute is just skewing the data. So I'm just taking away the mean squared. And the reason for that, because if the mean was 0, then all of these distances would be, you know, the mean of all these distances would be 7. But it's not 7, you know, if you like, they're the mean too big. They're the mean too big. So with the mean being 2, I have to then take away the mean squared because I've squared all the other distances as well. Okay, so therefore this is why it comes out as 3. So the next formula for standard deviation is that I just take all the distances. So I take the mean of all the distances squared. So take all the mean of all the heights squared, then take away the mean squared at the last minute. So that's another formula which I can do for variation. If you notice that is very, very similar to that. So if I write them side by side, so I've written them side by side, or one underneath the other. So let's just compare what's going on here. with this first one, what I'm doing is I'm calculating the distances first, then I'm squaring them, then I'm dividing through, so I'm taking the mean of those distances, right? But with this calculation here, what I'm doing first, I'm calculating the mean of the heights first. Then I'm just accounting, I'm making an adjustment factor, if you like, for the fact for using them, with the mean. So in other words, the difference between the two is, if you like, this is just the unpacked version of that, right? If you want to think about it like that. I mean, hopefully you can kind of follow roughly where it comes from, even if you can't necessarily vigorously mathematically prove it. It's just thinking about the same thing in a slightly different way. So this here, though, let's just look at this term here. This term here is just simply calculating the mean of the heights. So if you go back to my original sort of example in my graph, the mean of the heights is just simply whatever the sort of the speed was at that particular time. So, I'm just calling them heights. It's really the speed at that particular time. Well, how do I calculate the mean if it's in a, say, for example, a grouped data in tables? So a group data represented in table formats. So in other words, I have an X column with all my different speeds that I can have. Then I have the frequency column, which is how many times it can come up. Remember what I'm doing in the previous, I was doing in the previous video. Well, all I would do then is I just do exactly the same thing for working out the mean. So remember, the mean is just sum of fx over, the sum of f. Sum of fx over the sum of f. But it's no longer just working out the mean of the heights. It's working out the mean of the heights squared. So therefore, I'm going to have to stick a squared onto there as well. So another formula for variance is sum of fx squared over the sum of f, okay, minus x bar squared. But I mean, these two are pretty much the same thing. This is just for grouped data, and I've shown you sort of grouped data so much that I'm really not going to go through it in that much detail. If you just think, well, I'm calculating the mean of all my data values, but I don't just look at the mean, I have to just the values themselves, I have to look at the values squared, because obviously I need to just have them all as positive. So that's why I include a squared up there. But yeah, I mean, these are all the variances. And remember, how do I work out the standard deviation? So the standard deviation is sometimes called sigma, okay, because it's so important. The standard deviation is just the square root of the variance.